Hello, everyone. Thank you all for joining. It's time for another exciting lightning talk. I'm Parag Katkar, your host for tonight. I'm the Senior Director of Enterprise Solutions at Rhythm, and we have a lot of exciting content lined up for you in the upcoming weeks. Our lightning talks are hosted every Thursday at 5:15 p.m. Eastern Time, and each week, one of our practice area consultants speaks on the latest and greatest technology trends in the industry that will help you keep learning and growing in your career. And this week, Garik, who is an experienced engineering lead with us, is going to go over the comparison between JDBC and JPA. As a lot of you know, JDBC and JPA are two different Java specifications which take very different approaches to persist data. And Garik is going to go over all of those details. So I'm super excited about this. And without further ado, let's get it started, Garik.
Hello, I hope everybody doing well. Yeah, today we will have a really lightning talk, not too much. I will not take too much of your time. And we will do this comparison of JPA and JDBC. JPA stands for Jakarta Persistent API, formerly known as Java Persistence API. And JDBC is very old grandpa. It's a Java database connectivity. I have prepared some small comparison table and we'll go through this comparison. And at the end, we will see a small example of JPA, how to specify the entity, how to query database. And after that, I will be open for questions. So JPA is a Java standard that allows us to bind Java objects to records in a relational database. In general, it's not only relational, but currently it supports also NoSQL also. It allows the developer to retrieve, store, update, and delete data in the database using Java object. Several implementations are available for the JPA specification. And for relational database, the most popular one is Hibernate. And for NoSQL databases, the popular one is Eclipse Link. On the opposite, JDBC is a programming level interface for Java applications that communicate with a database. An application uses this API to communicate with a JDBC manager. Beyond the API is a vendor-specific JDBC compliant driver for the database we are using. As for JPA, it allows developers to construct database-driven Java programs utilizing object-oriented semantic. The JPA framework handles all the time-consuming error-prone coding required to convert between object-oriented Java code and the backend database. On our side, the JDBC allows us to write SQL commands to read data from or update data to a relational database relational database. For JPA, it is a database agnostic, which means that when we are switching from database to database, there is very few or almost no modification in the code. On our side, for JDBC, as it is a database dependent, in many cases, we will need to make some modification in our SQL scripts. The JPA framework uses only unchecked exceptions. Hence, we don't need to catch or declare them at every place where we are using them. And even though, for example, if you are using Spring framework, you can have a global exception handler where you can catch all these exceptions and just handle them. On the opposite, JDBC throws checked exceptions such as SQL exception. And here you have two options. You everywhere put try-catch blocks or declare exception in your method signature. The JPA serves as a layer of abstraction that hides the low-level JDBC calls from the developer, making database programming considerably easier. As for transaction management, JPA provides it implicitly. And for JDBC, we need to handle it explicitly by using commit and rollback. Now let's move to some small example. This is very simple, simplified example. We are declaring when we want to map an object to a table in database, we need to declare a class and annotate it as an entity, and which hints the framework that this class should be persisted to a database. And by table annotation, we are specifying to which table this class is being persisted. And here in the class, you see it's just a very simple POJO file where you are declaring your attributes, which will be mapped to the columns of a table. And as you can see, we have, for example, this ID annotation, which means this is your primary key. You can specify the primary key. And you see that on some columns, on some attributes, we have column attribute, on some we don't have. So if our property name coincides with column name, we can skip the column annotation. Otherwise, we are specifying column by providing the name to which column this particular attribute is provided, is mapped, sorry. And as of working with database, we don't need to write cumbersome SQLs or long select and so on. We just need to declare an interface which will extend a repository. In this case, it's a CRUD repository which comes out of a box with a bunch of methods, such as save, which inserts or updates a record in the database, or for example, find by ID, which searches a record in database by ID, and lots of other functionality. And if you need some specific, specific query, for example, if we need to search a record, let's say by parent, we are just specifying this method, find by parent. There is a naming convention based on which JPA can generate the appropriate query. So your finders should start by find by, and you are providing the name of a field by which you want to search. For example, if you want to make some more complex query, for example, if you want to search by parent and status, you are just declaring the method find by parent and status, and provide two input parameters. The order of input parameters should be kept so that it knows how to map the input parameters. As I mentioned, this is a very simplified way. So this example, it allows also to do a complex relation, as in database we can have many to one-to-many or many-to-many relationships, or one-to-one relationships. The same can be done here by using the appropriate annotations. And also in my example, you see that our primary key is simple by one field primary key. By JPA, you can also specify the complex keys where you have multiple fields as a key. In that case, you need to have a separate class where you are specifying your key attributes, and instead of this integer, you are putting that class. And for very complex queries where you cannot just declare in this simple declarative way, JPA provides so-called specifications. It's an interface which you need to implement, and by this specification, you can implement dynamic and complex queries by staying on Java objects. Still, you are programming Java objects. You are not going down to SQL level. Of course, both technologies, JPA and JDBC, have their pros and cons. But for example, I'm in the favor of JPA because it is simplified the work. It removes the boilerplate code and so on, especially in nowadays where we are working in microservice environment where we have just a couple tables in our database. We don't need to specify this complex relationship between tables. And in this case, we have pretty decent performance. And on this related tables, it can do a kind of lazy loading or eager loading, but these parts are out of scope. If you are interested, we can you can contact me later and we can discuss, or I can provide resources where you can find those information how to do this more complex stuff with JPA. In case if you have, for example, a very complex case, or you need really need some kind of performance, of course, you can go to pure JDBC, write your very specific queries. Yeah, and here are some resources based on which I prepared my presentation, and now I'm open for questions.